It's dead drill from a contractor. No, I'm not trying to fix this drill. I mean, it's completely dead. The buttons here is missing, plug cut off, everything's wobbly. What I want to look at is exactly how they did the hammer mechanism in it. And of course, I am really interested more in this and possibly if the motor works to reuse it for something else. I'm not trying to fix it, as I said. So let's open it. Let's have a look at the hammer mechanism. Things are in reasonably good condition inside here. Yes, now I understand why there's no trigger. They bypassed it completely. I assume this isn't working. I assume it's dead. There's no way the contractor will give me a working drill, so yeah, it's dead. So let's get to this and see how this thing actually works. But as you can see, it does rotate. Things move. So it isn't seized up. Let's have a look in there. So this is an extremely simple design. Essentially, this is an aluminum piece with a bearing in here, right? Some roller bearings, and that fits onto this piece of the shaft. Shaft comes through, that provides end support on this side and support on this side from that bearing. When it comes through, it engages on this. Essentially, this whole hammer mechanism is this is rough and that is rough, and essentially when we turn this one way, if you look inside here, you see there's a piece that's blocking the whole shaft from going all the way in. When it blocks the shaft from going all the way in, this doesn't engage that. There's a little spring just to keep it off when you basically have it in this form. So it just to make sure it pushes off. And when you do that, as you can see, when you do that, the whole shaft is available, the whole depth is open. Therefore, when you press on the drill in front, this piece engages that piece there, that little, and you get heavy vibration. And this isn't even held in. That's it. It's just a little pin, and here it allows it to go all the way back. So this and this engages. When you turn it this way, it doesn't. Rather simple. So this is not actually trying to take half a turn of revolution, put a spring in like a proper impact, like an impact wrench most would actually. So this is just really just creating an excessive vibration that works very well for concrete. The next quick thing to look at is the directional, which direction it spins, and that essentially, that little bar just turns this. This piece of plastic turns this way or that way. What it does is either contacts this contact here or the other contact on the other side, and essentially changes the polarity. So therein lies that whole mechanism. Extremely simple. It's fairly beefy, nice design, lots and lots of markings in there. I'll take a pic of that, and lots of markings in here, but I do not see anything that says fiber reinforced. I'm sure it is. It's a fairly good drill. I mean, Stanley is reasonably good. So yeah, a really simple mechanism. A little simpler than I thought it would have been. But this is really what I'm interested in. Oh, and the one last thing I'll get into. This, if we look at the design, it looks like it's a sintered bushing. It isn't machined. This is most likely compacted iron powder and sintered, so that you create a solid, but it isn't really, you know, like a normal cast solid that is machined. I'll try to take this off and see what diameter the shaft is. Really, 3/8 is ideal to work with the mill, but we'll see what we get there. But I need to machine that. Amazingly, this is my 3/8 drill chuck key, and it doesn't fit in this, so maybe I need to drill these holes out a little bit larger so this can go in. Initially this chuck was frozen. I've managed to take out the gear, take out the little bushing. I have to check what size shaft that is. Look like 1/2 inch. I'll clean it up, paint it over, put some rust coating on it, put some WD-40 here. It's no longer frozen. It's working perfectly fine. That's a success. At least I got one useful part for sure.